Is Mars colonization a distant dream or an imminent reality? Venture into the cosmos to find out. As we embark on this journey, let's begin by exploring the vessels that will carry us, the spacecraft. In the early days of space exploration, the concept of a spacecraft was rudimentary at best. We started with simple one-man capsules designed for short trips, like the Mercury spacecraft that carried Alan Shepard, the first American in space, on a 15-minute suborbital flight. As our ambitions grew, so did our spacecraft. The Apollo lunar module, a two-man vehicle, was capable of landing on the moon and returning safely to the command module in lunar orbit. This was a quantum leap from the Mercury days, marking the first time humans set foot on another celestial body. Fast forward to the space shuttle era, and we see a new breed of spacecrafts. These reusable vehicles, capable of carrying up to 7 astronauts, ushered in a new era of space exploration. They facilitated the construction of the International Space Station, launched numerous satellites, and even fixed the Hubble Space Telescope. Today, we're entering an exciting new chapter in spacecraft evolution. Companies like SpaceX and Blue Origin are pioneering reusable rockets, drastically reducing the cost of space travel. We're also seeing the development of spacecraft designed for long-duration missions like NASA's Orion, which is intended to carry humans farther into space than ever before. But it's not just about going farther, it's also about staying longer. As we set our sights on Mars, we need spacecraft that can support human life for months, if not years. And that's where the next generation of spacecraft comes in. Concepts like SpaceX's Starship, capable of carrying up to 100 people, are being designed with Mars colonization in mind. From rudimentary rockets to advanced spacecraft, human ingenuity has continually pushed the boundaries of what's possible. As we stand at the threshold of a new era in space exploration, one thing is clear. Our spacecraft are not just vehicles, they're our homes, our lifelines, and our gateways to the stars. The journey to Mars may be long and fraught with challenges, but with every technological leap, we're one step closer to making this dream a reality. To reach the stars, speed and efficiency are required. What cutting-edge propulsion technologies are set to revolutionize space travel? In the realm of space exploration, propulsion technologies have taken center stage. These innovations are integral in fueling our journey beyond the confines of our home planet. Ion thrusters, for instance, use electric power to create thrust. Unlike traditional chemical rockets, these engines expel ions to generate momentum, offering better fuel efficiency and the potential for higher speeds over long distances. Another innovative propulsion system is nuclear thermal propulsion. By harnessing the heat generated from nuclear reactions, these engines can produce significant thrust, providing quicker transit times for deep space missions. And let's not forget about solar sails. These devices capture light momentum for propulsion, making them a promising fuel-free option for interstellar travel. Imagine a spacecraft powered not by fuel but by the sun itself. As propulsion technologies advance, so too does our capability to travel further into the cosmos. Surviving in space requires more than just a spaceship. How are life support systems evolving to sustain astronauts on long-duration missions? Imagine living on a spacecraft for months or even years. It's not just about having enough food and water, but also about creating an environment that can support human life. That's where life support systems come into play, and they're becoming increasingly sophisticated. Oxygen generation is, of course, a key component. Engineers have developed systems that can recycle exhaled carbon dioxide back into breathable oxygen, maximizing the efficiency of every breath. Water is another crucial resource. With advancements in technology, we can now recycle almost 100% of the water on board a spacecraft, including sweat and even urine. And what about food? Hydroponics, the science of growing plants without soil, has the potential to provide fresh food during long missions like a journey to Mars. As we perfect the art of living in space, the dream of colonizing Mars comes ever closer. Mars, our next home. What does it take to establish a sustainable human presence on the red planet? Setting foot on Mars is an ambitious dream, one that comes with a myriad of challenges. The first hurdle to overcome is the habitat design. The Martian environment is harsh, with freezing temperatures, thin atmosphere, and high radiation levels. Our future homes on Mars will need to withstand these conditions, providing a safe and comfortable living space for astronauts. Concepts range from inflatable habitats to 3D printed structures using Martian soil, also known as regolith. These designs aim to provide not only protection but also self-sustainability with systems for recycling waste and generating power. Radiation protection is another vital aspect to consider. On Earth, we're shielded by our planet's magnetic field, but on Mars, astronauts would be constantly exposed to harmful cosmic rays. Solutions vary from incorporating radiation-blocking materials into habitat design to creating magnetic shields. The goal is to ensure long-term health and safety for those brave enough to call Mars home. But how do we build and survive on Mars with limited resources? The answer lies in the red planet itself. The Martian soil could be used to create bricks for construction, while the ice caps could provide water. Martian air, mostly carbon dioxide, could be processed into oxygen for breathing and nitrogen for crop cultivation. We'll need to be innovative, resourceful, and resilient, turning the Martian landscape from a hostile environment into a new frontier for human habitation. And as we learn to live on Mars, we'll also be developing technologies and strategies that could be applied to further space exploration, perhaps even to planets beyond our solar system. The colonization of Mars is not just about surviving but thriving. It's about paving the way for future generations to explore and inhabit the cosmos, pushing the boundaries of what we as a species can achieve. With every challenge we overcome, the vision of a Martian colony becomes clearer. As we stand on the brink of becoming an interplanetary species, what ethical and social questions do we need to address? It's a question that requires deep thought and careful consideration. In our quest to reach the stars, we must not lose sight of the profound impact space travel has on human psychology. Isolation, confinement, and the inherent risks of space exploration can take a toll on the mental health of astronauts. We must ensure that measures are in place to safeguard their psychological well-being. Moreover, as we contemplate establishing settlements beyond Earth, we need to address the question of governance. Who will make the rules in these extraterrestrial colonies? How will we ensure justice and fairness in an environment that is so drastically different from our home planet? Lastly, we bear a significant responsibility towards preserving space environments. As we seek to exploit the resources of other planets, we must be mindful of our actions, avoiding the mistakes we've made here on Earth. As we look to the stars, we must also look within, ensuring our journey into space is guided by our highest ideals. Our voyage through the future of space exploration has taken us from advanced rockets to the prospects of Mars colonization. We've journeyed through evolving spacecraft, innovative propulsion technologies, advanced life support systems, and the practicalities of colonizing Mars. But we've also touched upon the ethical considerations of becoming an interplanetary species. Indeed, the cosmos offers not just challenges, but also boundless opportunities for human growth and discovery. So let's continue this journey together, exploring the wonders of space and science. Until next time, keep looking beyond the blue.